Hello everyone, my name is Renuka Pechetti and I'm a postdoc at Liverpool Johns Moore University. Today I'm going to be talking about an intermediate mass black hole that we discovered in a globular cluster in Andromeda. This was a part of my PhD thesis, which was done in collaboration with Dr. Emil Seth. So globular clusters are dense clusters of stars that typically orbit a galaxy. A lot of these globular clusters have actually been speculated to contain IMDHs, like omega Sen or G1, but none of these detections have actually been robust. But if you consider these globular clusters as strip nuclei of low mass galaxies, they can potentially contain intermediate mass black holes in them. This has been suggested due to the recent discoveries that have been done by our group in ultra-compact dwarf galaxies, which was earlier presented by Anil. And these contain black holes of around million solar masses, as you can see here. These were the detections that were made by our group. And we also have discovered a lot of low mass galaxies that contain these black holes. So there's a pretty high possibility that the low mass galaxies can be stripped, and these stripped nuclei would contain black holes, and which can also be seen as globular clusters. These are important for our black hole demographics because the IMBHs can distinguish the black hole formation scenario in the early universe, where if IMBHs are found, they can actually be considered as seeds in our early universe. So the way we did is we took the data from HST for this cluster in these two filters, as this was the most luminous cluster in M31. And we created mass models assuming a constant mass to light ratio in this cluster. And then we combined this mass models with the kinematic data from Gemini NIFS. And we used genes models to estimate a black hole mass from this for this cluster. As you can see, the dispersion rises towards the center, and also there's a pretty strong rotation observed in this cluster. So we performed MCMC simulations using the genes models, and we estimated a black hole mass of around 8 times 10 to the 4 for this cluster. This is kind of degenerate with the mass to light ratio, and isotropy, and the inclination, which we used as parameters in our models. And they were pretty well constrained with the mass to light ratio and isotropy. As it is pretty spherical, the inclination did not affect the black hole mass, and it was close to being isotropic as well. There was a discrepancy with the extinction in this cluster because it is not well determined, but that does not affect our black hole mass at all. And as you can see here, there's a pretty rise in the dispersion here, velocity dispersion for this cluster. And the no black hole model here in the orange is pretty much excluded with greater than 3 sigma significance here. We also have additional evidence suggesting that this cluster might be a strip nucleus in M31 because the light profile that we derive for this cluster is a 2-component profile, which is typical of a nuclear star cluster where there's an outer envelope in it. This is one evidence, and the other evidence suggesting that this is the most massive cluster in this galaxy has a pretty high chance that it can host a black hole. So to conclude, this cluster that in M31 contains an IMBH of the order of 8.5 times 10 to the 4 solar masses. And we have evidence suggesting that it can be a possibly strip nucleus of a low mass galaxy. Thank you.